Hello everyone, so this video is going to be more of an in-depth look in how to build RESTful APIs in Go. And I have made a video previously to this one where we have built a project manager API, but I've got a lot of people asking for a more complex and production ready project. So I've decided to create this one video / course that will teach you just enough for you to be able to go on your own and not having to watch another video on how to build APIs in Go. I've made some decisions in this video to keep things basic, and I want to keep things basic on purpose because I want to teach you the basics. I see a lot of tutorials out there that teach you all of these frameworks, but you gain no value at the end. And when you want to switch from framework to framework, you'll have to learn that framework again. And if you base your knowledge on a specific tool, you'll have to relearn all of that over again. So that is why in this course that I've kept myself to the core basics, so that if you want to learn a new framework, or a new package, you can do it more confidently and on your own terms, which is more fun in my opinion. And there is a couple of ways you can watch this video to get the maximum value. You can either code along with me and you can watch everything sequentially. There is a lot of information that I will cover, or if you're just looking to learn something specific, you can quickly jump to that part in the video notations below. I'll make sure to add them. And at the end, I have prepared a couple of exercises where if you want to put your knowledge into practice, I have written some improvement exercises for you to try them out. So with that out of the way, basically what we're going to be building is an e-commerce API. And in there, we're going to create a bunch of things, such as we're going to add authentication, we're going to create all of these endpoints here, we're going to test everything. So we're going to create unit tests for everything. We're going to connect to an external MySQL database. And at the end, we're going to also Dockerize everything so we can just ship this image to the cloud and everything is done. And I'm going to show you how you can create all of these services and how they can communicate between them. And we're going to also do that with dependency injection. So it's going to be very easy to test. And we're going to create everything using migrations on the database, so we can just reproduce everything here on any database you want. And for example, here on the checkout endpoint, there is going to be a lot of calculations done here because we're going to have to do inventory management. So we're going to check if the product that the user wants exists, if they have enough stock in the database, and then we have to calculate the total and send an invoice to the users. So I think this is a very cool project for you to build. And then again, at the end of the video, I will leave an improvements list so we can actually make this project a bit more of your own. All right, so let's actually get started. And here I have created a directory called ecom, and I'm gonna go mod init and create the name of the project. So I'm gonna point to my GitHub repo and then the name of the project. So the very first thing that we're going to do is that we need to create an HTTP server. So for that, we need to create some sort of a handler. So let me go here and actually start by creating a CMD folder. So in Go, it's convention that we store entry points of the application in CMD. Usually when I create APIs, and in this case, we're going to have two entry points. The first one is going to be the API itself. So let's create the folder for it. And then the other one is going to be the migrates. The migrations folder is going to be a separate program from the API. So inside here, let's just create an API.go, and it's going to be inside the package API. Then here on the CMD, I'm going to create a last file, which is going to be the main.go, and this is going to be on the package main, and this is actually the entry point for the API. So here I'm going to create a main function. And this main function is going to create a new API instance, so a server instance that we are going to create here. So let's create actually a new struct called API server. And here we're going to hold the address, so it's going to be a string. And then we're going to also add the database, so the SQL.db. Then let's create a method called new API server. So this function here is going to create a new instance of the API server. So here it's very simple. Let's just return a pointer to API server, other db, and then the method that we need to create here is the run, because here on the main, what you're going to do is that we're going to have a new server instance. So we can actually just go here to API.new API server, pass in other. We don't have these informations yet, so I just paste here a string with 8080 and then the DB, which could be null for now. And what you could do is here do a server.run and we check if there is an error. And if there is an error, we basically just log it to the console. Now the run function will do a couple of things. So the first thing is that it's going to initialize a router, register all of the routes, so register all of the service routes and their dependencies, and then at the end we're just gonna listen and serve for the router. So here we have the other from the instance, and then we can pass in a router. So for the router, I usually go with Gorilla Mux because it's simple enough. And although I'm using the Golang 1.22 and I have built projects without using any dependencies on it, but I know that most of you are not on this version of Go. So I'll keep using Gorilla Mux for that reason. So here, let's create a new router. Now, if you want to switch the routing for anything you'd like, this is the place. So just need to change on one place, and this is going to be very modular. And then I'm going to also create here a new sub router. So basically, this is going to be the /API v1 prefix. First thing here, we need to actually import Gorilla Mux. And then here we can actually use the API path prefix. And then the prefix is going to be API/v1. So the reason behind this prefix is so that if the API changes in the future, we have a new version. So we can just increment it to version 2. This is because clients that might be consuming our API should not have breaking changes. So this is one of the specs that RESTful APIs should have. Then I'm just going to add here a logging. So now that we have the subrouter, we can actually go here and start creating our handlers. But this function would become pretty messy if we start creating our endpoints here. So we are going to separate everything into services. So why not create the routes in the service itself? So the first service that we're going to start with is the user service. So let's go ahead and create a routes.go. And each service is going to be of type handler, where the handler can't take any dependencies. So this is where the dependency injection comes in. And let's just create a new constructor for the handler, new handler. And for now, just going to return the handler, an empty one, like so. And as we wanted, let's create here the register routes function. And this function is going to take in the router. So this is going to be the subrouter. And what we can do here is do router.handleFunc. And here it's a signature. So first is going to be the /login, for example. And then here is going to be the handler. So here we're going to have a new method for the handler. Let's just create an empty function here called handleLogin. And put it here. Now this receives an HTTP handle func. So if you recall what that is, it's going to be a response writer and then a requests, a pointer to http.requests. And here you don't need to call it. And the methods for this endpoint is going to be /post. Let's duplicate this for the register as well. And I'm going to just duplicate this function here. Call handle register, and here we have an example of a service. So all of the service is going to be pretty similar following this structure, so we can actually make them very modular. So here on the API, let's go here and create the user service, or actually user handler, whatever you prefer to call it. Going to be users from my package, and here I create a new handler. And then what we do is that we do user handlers.register routes, and we pass in the sub router, so they are prefixed with the v1/API. And this is pretty much it to register the HTTP server. So here on the main, we should be having a server connected. So let's go ahead and do a go run cmd main.go. And we have the server listening on port 8080. Now, I don't want it to be typing go run every time. So what I usually do is I create a make file. And here we can create a couple of commands that then we can just reference them easily on the console. And this is what I'm going to do. So here I have a build command, a test, and the run. So whenever I do make run, it's going to be the same as doing the go run cmd.main that we just did. So that is done. So here on the login, there isn't much that we need to do. It's pretty much set up. So this is how we're going to register all the routes across all of the services. So for this one, just for the users. But whenever we want to register routes, we can just come here and add a new service. So the next logical step would be to fill this with the database connection. So let's go ahead and actually do that. So here I'm going to create a new folder called database or db. And in db, I'm going to create a db.go. So this file, all it does is going to create a new MySQL storage. So let's just call that new MySQL storage. And it's going to receive a configuration from the MySQL package. So this is the driver package that we need. So whatever database you're going to use, you can just change the name of this function and import the driver that you want. So whatever database you're going to use, you need to import accordingly to whatever you want. So I assume that you know what you're doing then. Here we have the database connection that we need to open. And it's going to be MySQL, of course. And here the configuration, let's just transform it to a format DSN. And then let's handle the error, where here basically could just log.fatal. If the database is not working, I mean, there's not much we can do. And we return the database and a nil error. So here that on the main, what we can do is that we can get the database from db.newMySQL storage. And here we pass in a configuration. So let's go ahead and create one. MySQL.config. Now the first thing that we need is a user. So I'm gonna put this as root. Then the password is going to be something. Then here we need the address. Now the address is going to be the combination of the host and the port. So it's going to be something like, this is just a default value. You're going to come to this into bits, like so. And then we also need the db.name, which I'm going to call this e-commerce or ecom for short. Then the net is going to be TCP. And I am going to set the allow native passwords to true. And finally, the parse time to true as well. Now, of course, we don't want to have these variables here hard-coded because these might not be your variables that you have for your connection, or if we're going to deploy this into the cloud, it doesn't make sense to have the password and the user here hard-coded. So the best way to handle this is with environment variables. So let's actually go ahead and create a new folder called config. So this is going to hold all the server configurations. And the first thing that we need is the environment variables. And if you're familiar with any of my videos, this is what I usually do. So here we have a type config, which is going to be the variables itself. So these are the variables that we have just written. The only thing is that here I have the server port and the server host as well. And here are the database variables. And then what I like to do is create a function called init.config. So this is going to return a configuration object. And here we return the config, the struct, and here we populate pretty much all of the variables. And to get the variables, let's create actually a function called getEnv below here, which takes the key and a fallback. So in case the key does not exist, so in case the value of the key does not exist, I mean, so we get the value from the, I think it's os.lookupenv, and here we pass in the key. If it is okay, then we can just return the value, else we just return the fallback instead. So Here is the key. I'm going to just call it public host, just like the name, and the fallback is going to be http localhost without the port, because then the port here below, it's going to be the same thing. So port and the 8080 is what I usually use, good default, and then for the DB, it's just the same values that we have written, so I'm just going to pass that forward. Here they are. The only thing here is that I have dynamically populated the address from the host and the ports. So then here on the main, now we can actually change these values here, but before that, I don't want to be initializing this function every time. So I'm going to create a singleton called Envs, which is going to hold the initial configuration. So this is going to be just a global variable that we can access like so. So I can do configs dot or config dot envs, and then we access the user like so, db user, and I'm gonna replace for the other values as well, like so. So these are the new updated values. I'm just gonna pass here the database below and handle the error, which we can just do a log dot fatal again. Now there is just one thing missing in case you're using the .env file. So I know a lot of people like to have these .env files with the variables here. Usually what I use is a tool called dir-env that directly injects the environment variables into the runtime. But I know a lot of people like to do this. So what I'm going to do is I'm going to include the go.env. So if you go here to the browser, this is the tool that we're going to use. Basically, all we need to do is call the go.env.load, and it's going to read all of the variables that we have here on .env and load them into the environment runtime. So to do that, let's just copy here this, import it, and this is done. So to test that out, let me do a make run and see if everything is running on the same port, so 8080, and we need to do some we need to initialize the database connection because we have opened it, but this does nothing. This does not connect to the database. For that, we need to do, I'm going to call init storage and pass in the pointer to the SQL database. And then here what we do is the db.ping, and this is what actually starts the database connection. So it checks if everything is all right. And here we just log.sprint and say that the DB is successfully connected. And we just call this after we have, like here, pass in the database. Now, before we can test this, we should actually create our database. So here on my SQL editor, basically you can create your database, whatever name you give it. And then we can actually go ahead and test this, and we should be connected to the database. So if you get an error, something is wrong with the credentials, most likely. So with that, not only we have covered the environment variables and how we can configure our server very easily, and we have also connected to the database. So let's then start creating the register endpoint that we were here. Let's start with the register. I actually need to change this to the correct one. So the first thing that we need to do here is that we need to receive some sort of payload, some JSON payload. We need to parse it, validate it, and then we need to check if the user exists. So let's start writing that. So here we do the get JSON payloads. Then we need to check if the user exists. If it doesn't, we create the new users. So this is pretty much the flow. Now to get the payload, let's create here a new folder called types. So this package types here is going to contain all of the application types, so we can use them all over across the services. The first type is going to be the register user payload, which is going to have the first name. So we're going to create a user's first name. Then we have the last name, maybe the email, and of course the passwords. So this is going to be the structure. Then the next thing I'm going to add is the JSON marshalling here. The first name like this, and the same for the last name, the email, and then the passwords. Then here all we need to do is get the JSON.newDecoder, pretty standard. Then we pass in the body and we decode it into a variable. So I'm going to call this payload, which is going to be the types.register user payload. So now we are decoding the payload into this object, and before this we should also validate if the body is actually nil. Not only that, but if you think about this function, this here could be moved into a reusable function that you could use across all of endpoints, because this is something that we're going to use constantly over and over. So let's do that. Let's go here and create an utils. And then create the utils.go package utils, and here let's create a function called parse JSON. So it's going to receive the requests, a pointer to the http.requests, and a variable that's going to receive to decoding. So it's going to be the payload. I'm going to call this, it's going to be any, could be anything. It's going to return the error, and let's move this logic here. We could just return instead. We don't need this, so this is going to stay here. We return it, and here we can return an error. That's the missing request body. And here what we do is that we check if there is an error from this call, and we can do utils.parseJSON. We pass in the body and the payloads. And if there is an error, we need to write to the user. Again, let's take this opportunity to create a new reusable function here that basically is going to return JSON. So we have the parse JSON, and we can also do a write JSON here. It takes a response writer, a status code, and then anything that could be the output. It's going to return an error as well. The first thing we do is that we set the header for the contents type. So this is going to be a JSON API. So let's add the content type for application JSON. Then let's write the status codes here as well. And finally, let's just return this into a new encoder. This, and then we encode the payload out like so. So here we have a function to write JSON to the user. I'm going to take this opportunity to create as well just another one. This is the last one, I promise, which is the write error. Now there is a good reason to create this function. Now this function is just going to write JSON, and it's going to do pretty much this here, but the payloads, the v, is going to be of type error. So the reason for this is that we can have a standard output to the user whenever there is an error. So I see a lot of APIs out there that return errors in multiple ways, a string, an object, and this way we can reuse this function every time we want to use an error, or in this case return an error. So this is going to be the signature. Now the advantage of this is that we are consistent, and any front end, any client that consumes this can expect an error in this signature here. So let's do this here. Write error. We need to prefix it with utils. Write error, which in this case is going to be a bad request because it's an error from the user. And here above we should also pass in the request, not the body. And this is pretty much it. So we've added a lot of util functions that is going to speed up the development of the next endpoints. And on this step here, we need to actually go to the database because we need to check if the user exists. And to do this, we need to go to our storage, to our MySQL, and check if there is a user with the same email as the one that is requesting the register. So the way that we're going to handle this for the services is that we're going to have a storage layer here. I usually call this store. And if you're familiar with the repositories pattern, this is what we're going to do. So all of these store.go files are going to be repositories. So this here is pretty much a repository. It's a type store, which depends on the database, and it uses this database to make queries. So for example, let's just create here a new store like so, and return a pointer to store. And here we return store database. And for example, this is going to be the user. So let's have here a method called get user by email, and it's going to receive the email, and it's going to return a pointer to user or an error. Now we don't have yet this user nor this type. So let's go ahead into the types and create our user. And if you remember from the beginning, this is how we have designed the user structure. So it's going to have an ID, first name, blah, blah, blah. And this is what we are translating into Go here, into the structs. So now we can just import the types, and it should be working. Awesome. Now, as I've said in the beginning here, you could use anything. You could use an ORM, you could use SQLX, which is a very good solution here, actually. But I'm just going to use the raw SQL here, the queries. It's going to be very simple, it's not going to be much. If you want to abstract this away, you can easily do, but at least you know what's happening here on the repository level. So we're going to search by email, pass in the email. If there is an error, we can just return nil. And now we need to scan the user. So let's do a pointer to an empty pointer to user, and then we can just loop over the rows dot next. And if there is something here, usually I like to do here is create a function called scan row into user, because a couple more functions are going to use this functionality. Basically, it receives the rows, which is going to be a pointer to the SQL.rows, and then it just returns the pointer to types.user error. And here we scan it. We need to create a new empty types.user and scan the rows like so. So we use the scan syntax. And here we basically pretty much just filling up this user with the columns that are coming from the database. So the user dot first name, last name, email, and password. You can also pass here the created ads, and at the end we just return user and nil. You should also handle this error. If error, like so. So that here what we can do is we can do this. So scan user into row, pass in the rows, handle the error, and actually we can just return here, because if there is a user, we have it, and if the user.id is actually equal to 0, it means that it was not found as well. So we need to handle this case, and I'm going to throw an error calling user not found, and at the end we just return the user and nil, like so. And here actually it's not a new declaration, so we need to remove that here for this to work. So with this we have our first repository. Now we need to inject this dependency into the routes handler. So to do that, if you remember, all we need to do, just like the store repository, we need to say that it depends on the store. So it's going to be depending on the types dot user store. And let's create this type as well. which is going to be an interface. Now the trick here is that this is going to be an interface. Now the reason why is that we can actually easily test interfaces in Go. Let's say, for example, that this is the function. So this is the interface that we just created here. And this is the implementation, which actually matches. So it means that any instance of this store here is going to be a valid variable for an interface. And if you want to create a test to test these routes here, all you need to do is create a mock interface of the user store. It could be just a very simple function like this, which has to have the same signature. So it would need to return a user as well. And here it could just return nil, mock user store, for example, which could be a struct. So this mock user store here that is just created very quickly, it's a valid dependency for the user routes here, so for the user service, because it implements this interface. So you can see how easily you can actually create tests using this approach. Now the user store is going to have a couple more methods. We can just define them here. For example, it's going to have the get user by ID and then maybe a create user. So this is what we're going to call next on the register. So let's go ahead and create the empty signatures for those methods, and then we can implement them like so. So just returning nils, and then we come back to these guys and implement them. And now let's actually see if the so here, let me save this, and then on the API.go, let's create now we need to change the new handler actually, because it's receiving a new dependency. We need to initialize it, so it's going to be this here, like here, but actually this is not, should not be a pointer. And let's just set store equals store. Now in the API.go, we need to update here to receive a new store. So it's going to be the user store. So let's create here user store, user.new store, and it's going to receive the database. So it's going to be the s.db. And this is how you can easily do dependency injection in Golang. Now let's go back here to the register and do the h.store.get user by ID. So now we can have access to the repository in any method that we want to create. Let's pass in the payloads.email. Check that this returns a user and an error. And here we check if the error is equal to nil, and if it is, it's because the user actually exists, so we don't want to proceed, so we just return. And then if the user actually does not exist, then we can easily create it like so with the method we have created. And this is pretty much it for the first stage. I'm just gonna handle here the error very quickly as well, and then we can do is return to the user with the right JSON, pass in the status created, like so. Now you might have noticed there is a small problem here, and the problem is that we are not encoding the password. So whatever password the user sent is going to be stored on the table as plain text, and of course we don't want to do that. So first we need to hash this password somehow. So let's store that into a variable here. And for now I'm just gonna keep it as a string here and replace it. And to hash this password, what I'm going to do is that I'm going to go into the services and I'm going to create a new auth service. So everything related to authentication, encryption, I'm going to store it here, and I'm going to create a file called password.go. In here, I'm going to create a function called hash password, and it's going to take the original passwords and convert it into a new string or return an error. So when it comes to authentication, encryption, all of that stuff that makes your application secure, I usually like to, and I recommend relying on external tools that are bulletproof, that are on the industry. So one of them is bcrypt, like so. So you can just import it and download it. And they have a function called generate from passwords, where you pass a bytes, so it's going to be the password has bytes, and here you pass in the default cost or any cost. I just like to use the default one, like so. I'm gonna handle the error, so if there is an error, we can just return an empty string and an error here. Else we can just return a string of the hashed, and we don't have an error. Now let's go back to the routes, and here you can do auth.hashPassword, pass in the payload.password, and also handle the error, like so. Now here we are passing the hashed password and not the plain text password. Now this looks fine for the register endpoint. I think we are pretty much done with it. So there's two things that we need to do. First one we can of course is test this, but we do not have any tables created in our database, so we need to create the migrations. But first let's create some tests here. Let's create a route.test.go and test this route. So here I'm going to create a function that is going to have all of the endpoints. So I'm going to do everything here, call out test user service handlers. And the first thing we need is a handler. So the user service handler, which is going to be just new handler. And here we need to pass the dependencies. So we need to pass the user store. Now this is where I've mentioned that we could easily mock, because this here is an interface. So as long as we have an interface that obeys this signature here, we are good. So let's do that, and I'm going to show you how you can do this for all of the tests that you do. So here, let's make a user store, and this is going to be of the type mock user store, for example. And let's create this type below here, hidden. It's going to be an empty struct without anything. And then the most important part is that we need to implement the methods from the interface, right? So let's go here and double check. So the first one is, I'm just going to copy this here, open a new window actually, like so that we can see what we need. This needs to be types.user. And here we don't need to implement anything. If we want to implement something, you can actually implement here any custom logic, so you can test against that. And I'm just going to do the same for the other ones. So this should be it. I've just added these two, and if you take a look, the error is gone here. And if I just remove this function, you can see there is an error, which basically says that it's missing this method to be a right interface. So let's start with our first test, which, for example, should fail if the user payload is invalid. So all tests are going to be pretty similar, so I'm going to focus and explain this first one, and all of the subsequent tests that you do, I'm going to skip ahead and just show you what it does, so you can just learn once and then you don't have to hear the explanation again. So we're going to make here a request to that endpoint, so the method is going to be a post method, and then here it's the URL, which is going to be /register. And then here it's the body. Right now we need to pass in the payload, so let's make one here and encode it, because what we want is types.register user payloads. Need to pass the first name, like so, something random. Here I'm going to keep the email empty. I could pass, for example, some random passwords. And now we need to, this accepts here a reader. Now we need to first do marshals into a JSON.marshal, and here we pass in the payloads. I'm going to ignore the errors and pass in here into a bytes.new buffer and pass the marshals. Then I'm going to handle here the error very importantly and do a t.vital, so we stop the test. So the test fails. Now that we have a request, what we need to do is actually make the request against the handler. So let's make a test recorder, http.test.new recorder. Then the router, which is going to be a max.router, or depending on what router you have. Then here what we do is we do router.handlefunc. So it's just like the registering. And here it's the URL, so it's going to be the register, and here we pass in the handler that we want to test, which is the register handler. And here we make to serve HTTP the request we just made, like so, and the recorder. Basically, the request is made now. All we need to do is check that the request or the response code is if it's different from a bad request, because here on the register we are throwing a bad request if the user has an invalid payload. So basically we need to file here, and I'm gonna say unexpected status code, and it should be the correct one here. So let's go ahead and run this test. So the test passed, so it seems to be everything all right. So let's actually make it work. So I'm gonna pass in here a mail. Actually, I'm gonna keep like this, just to show you that this is an invalid email, but it's gonna work, and that is going to be a problem that we're gonna fix. And you can see that something is wrong here, because the test is still passing, even though we are passing a valid payload. So this function here is not being called. So actually the test is still working, it's still passing, although this here should of course fail. But what's probably happening is that it's going past here and it's failing either here. Actually, it's probably just failing here. So basically the error is going to be nil. Yeah, it makes sense that this function here it's failing. So how can we do and make this function actually not show no error? So that's where we can come here into the get user by email, and for example instead of throwing a nil error, let's for example throw new error, say user not found. So for example, it's the first time the user is registering, and if you run this test now, it should fail. Now the test did not fail, which shouldn't have, and I think the reason is that here on the parse JSON there is a couple things here. So first is that we need to add this return that was missing, and then the second one is that here we need to pass in the pointer, so otherwise the payload is not being filled, so that was why it was failing. So if we try again, we can see that it now fails. So the status code is 201, and of course it's not what we want. So let's try to make this failing again. It keeps failing. And the reason why it's still failing, even though the email here is empty, if I even remove it from here, I think it will still pass. And it makes sense because the here the parse JSON it's doing his job. So if I actually did this, so to actually make this fail, for example, just to show you, let's go back here to this email. I'm gonna remove this. I can remove this, and here I'm going to pass in nil. So basically I want to match this condition. If we try again, you can see that this passes because it failed. So if the user sends an empty payload, it's going to catch here on the parse JSON, so we can make sure that that part is working. But what I want to test here is that really passing an empty email or passing something that is not an email, it should fail. And for that, we need to validate. Not only we need to parse the payload, but we need to validate the data on the payload. Now for that, you could easily come here and validate it. So validate the payloads, and we can do it as simply as just having a function where we check the payloads.email, we check the username, all of that. So that becomes a bit verbose if you want to scale this into more endpoints and all of that. So there is a pretty cool tool that I like to use for this. So it's a very small, low print package. And the reason why it's so special, it's because all we need to do is come here to this signature here and add a new field. For example, let's come here and add the validate. And for example, the first name needs to be required. So we say that it's required. I'm going to do the second the same. And the email needs to be of type email as well. And for the password, it needs to be required, and it needs to be a minimum of 3 and a max of let's say 130. And then here on the routes, let's go ahead and check how we can use the validation signature. So this is the package. It's very well known. And the way we do it is basically we can just import it and validate the struct like so. But first, I'm going to make a reusable function here called validate, where I'm going to call the validator like so from the version 10. And then I say new. This basically is going to be a singleton for this validator, and we need to import it. So every time we want to use the validator, we do it here. Reason I'm doing this, it's because here they recommend us for doing caching. So every time we want to use it, there's no need to initiate a new instance. We can just reference to this one. And here all we need to do is let's just check the error from the validation. So utils.validate.struct. And here we pass in the struct, which is going to be the payload. And if there is an error, we're going to create an object called errors. And we're going to say that the type of this error is going to be validator.validation errors. And then we're just going to throw to the user that he has errors in the validation. So it's going to be a bad request as well. And we're going to try to send multiple errors to the user this time. So it's going to be invalid payload, where we pass in the message here from the errors, like so, and we return. So let's go back to the test, and actually I'm going to keep the email as invalid. So we are expecting this to work because it's going to throw a bad request, so it's going to fail. Let's see if that is the case. And we got some pretty bad errors, so something is wrong. I see, so I made a typo here on the types. So here, yeah, instead of being mix, it should be min. Does it make sense? So let's go back and try again. And here we got the test passing. So we got a bad request. And what happens if we make a valid email? Basically, the test should fail. And it fails. So we can make sure that this test is working. And let's move to the next one. And let's, for example, test the happy flow. So just to keep it short, let's try to see should correctly register the user. So this is the flow where we send all of the payload correct. So let me just copy everything here and paste it down below. And here, let's make this a valid email. And here I'm just gonna say invalid to make it obvious. And these should throw a created, like so. And let's go ahead and test this. So both tests passed. Awesome. So as you can see, it's pretty easy to test your endpoints here in Golang following this structure. It's just functions calling functions. There's no magic, there's nothing, anything here. So of course we want to test this functionally and see if we make an HTTP request, if everything works and we have something in a database. So to do that, first we need to create the tables. We could go ahead here and create them manually, but that is not reproducible in other developers' machines. For example, if you have a team of engineers and they had to create the tables manually, that would not be very pleasant for them. So let's create something that they can just a script that they can just run and create the tables on their machines. So to do that, let's go here into the CMD, migrate, and let's create a folder called migrations. So database migrations is a way for us to keep the history and the changes of the database. So we could have some changes to the database. All we do is create a new migration, we update the table, update the column, we create some new data there, and all of that is going to be here on a log of migrations. All we need to do is execute them. Now the advantage of this, it's like Git, so we can have an history of the changes, we can have an history of all of that. But a really good benefit from that is that it's reproducible. So if you run it once, it should be the same output every time. So to get started, let's go here into migrate and let's create a new main.code. This is going to be the entry point for the migrations. And here we're going to use our last tool, our last external tool. It's going to be this migrate. How it does, it handles all of that. It takes, for example, our MySQL driver that we already have installed. So we don't need to do much there, but we need to write here a little function that actually executes and connects to the database. So let's do that. So this is going to be a new program. So it's going to be a main here. We can do that. And we can reuse the code that we also have on our main. So this here, where we have the connection to the database and the configuration, we can copy this. And then here below, we can use the tools It's called migrate, and it's going to be this one, the Golang migrate. Let's just check, it's the v4, that is correct, so let's import this. After that is done, let's use the new with database instance. Here you pass in the source URL, which is going to be where we have our migration. So it's going to be cmd migrate/migrations. It's the folder that we have just created here. Then we need the driver. It's going to be the MySQL one, and we pass in the driver itself. Now for the driver, what you need to do is initiate a new driver here. So let me actually go to the database, to the documentation, and check the documentation for our database here to MySQL, and let's see what do they recommend. So here they are creating the driver like so. So let me just copy and paste. And this MySQL, let me see if it's coming from, yeah, it's coming from here. So this is the driver that they have. And this one here, we actually need to rename. This one is coming from, so this is the one that we had. Let me just do MySQL config, do like so, and that should be it. So here we have the driver, pass in the driver, but I'm gonna handle the error. If the error is different than nil, I want to know why it failed, like so. Now here they also import the source file like so. So let me just make sure that I have that. And here they import the Go SQL driver, but we already have it because we are passing the configuration here. So we are done with that. Here I'm gonna also handle the error. I'm gonna copy paste. And now all we need to do is either call m.up or m.down depending on the migration, because when you create migrations, there's two types. There's the up and the down. If you want to do the changes, you call the up or the latest. And if you want to revert, you need to call the down. So it's going to revert all those changes. So here let's see what command we want to pass into our CLI. And then here, if the CMD is equal to up, we do something. If the CMD is equal to down, we do another thing. And let's just call the method that is the m.up. It throws an error, so we need to handle it as well. So if the error is different than nil, and if the error is different than migrate dot no change, here we log it. And I'm going to do the same for down, but change the commands to down, like so. So of course here this is an entry point to our application. So let's go to the make file and add a new command here. I'm going to call the first one to create a migration. So it's going to be the migration create. So if this command fails on your machine, all you probably need to do is install their CLI on your machine as well. So here you probably have instructions how to do that. You can use on Docker as well. But after that, you can just execute this command. So this command here, I have it already. I'm just copying it on another monitor here. Just like so here. So we can create a migration. Let me just add the others too. So it's going to be the migrate app. It's going to be go run cmd. And this is going to be the path. And then I'm going to do the same one for the migrate down, like so. And this is how we can do it. Let's try and create our first migration. So here let's do migration. And let's add, for example, the user table. Add the user table. There we go. It worked. Here we have two files, as you can see. So the first one is going to be the down, and here we have the up. So all we need to do here is create SQL. So we can just write SQL statements here. These are SQL files that are going to be executed. So what we want on the app is to create the table users if it doesn't exist. For example, create table if not exists users. And then here it's just going to populate the properties that we want. For example, it's going to have an ID, which is going to be an unsigned integer. If I can type, it's going to be an auto increment. I'm going to remove here the primary key. It's going to be not nullable as well. And I'm going to move the auto increments to the last here. I like to have this formatted like so. And then here you're going to also have the first name. We already know that, which is going to be, for example, the last name. and the email, and I'm going to keep filling the fields like so. So this is the same structure that we have on our types. If you check the user, the only thing here is that I define the primary key and the unique key on email, so you don't have duplicated users. Now here on a down, what you need to do is drop table if exists users like so. Now to run our migrations, again, make sure that you have your database created called ecom or the name that you give it, and then we can run the commands make migrations. How much was the name? It was migration up, like so. And now if you go here to the database, if you refresh, you can see here you have the users table. And cool thing is that if you do the down, you can see that the user table got deleted, but here you still have the migrations empty. So this is some metadata that the package creates. Now, since we're here, why don't we create all of the migrations to create all of the other tables? So the products, the orders, and the order items. So that is what I'm going to do now. So here I have created the products table. This is how I made it. And I have also did the order items and the orders. So if you want to follow along, stop the video and copy along, or you can get the repo from the description below. Now let's go ahead and run all of this with make migrate up. And if you check, here we got all of the tables. Now, before we can test, we need to actually implement here the get user by ID and the create user on the repository for the user service. So let's start with the create user. So here it's pretty easy. All we need to do is do an insert into the users table. So let's do inserts into users, and we're going to insert the first name, last name, the email, and the passwords, the hashed passwords. And the values are going to be 1, 2, 3, 4. And here we put the user.firstname. If the error is different than nil, we can just return it. Otherwise, just return nil. We don't care about the response for now. If we need it, we can add it. So that is done. So let's go to the get user by ID. And here it is. So I just copied from the get user by email and changed here the where parameter. So it's very similar to what we have done. So let's go ahead and actually test this. So let's do make run. And now here I'm going to open my HTTP client, which is called standard client. And here I can make an HTTP request. You can use Postman or whatever you prefer. So here I'm going to send this payload, the email, valid password, and the first and last name. And if we hit send, we had 201. And if we check here the database, we can see that we have an entry with the user ID 1, and here is the password hashed. So that is working as well. And if I try to send a new request, we got a bad request because the user with this email already exists. So let me just try again here an invalid payloads. And here we got also validation error. So let's quickly move out and implement the login. So the login is going to be very similar to the register. So here we can actually just copy this here. And instead of this payload here, we can copy and paste here to be the login user payload. And here I'm going to delete the first name and the last name. We don't need this. And here this validation, it doesn't make sense as well. Both fields are required. So here, let's change. Now the next step is, now that we have the payload, we need to find the user. So let's go ahead and go to the store, find user by ID or by email in this case, and we pass in the payloads.email. Again, we can copy from here the, actually we cannot because this is a different validation. So let's do it and don't be lazy. And we just return not found, invalid email or passwords. So we're not going to say what it is. So the next part is we need to check if the passwords match. So the password here on the database, which is hashed, and the password, which is plain text that we just send on the request. So if you think about it, you need to hash the password that was sent and compare both passwords. Now we can do that with the help of the bcrypt package. So here we can actually create a function called compare passwords, which is going to take the hashed passwords, has a parameter, and then the plain one has a string, has a slice of bytes, and return a boolean. And here, all we do is you call bcrypt.compare hash and password. So it's going to do what we have explained. We pass in the hashed and the plain, and we return the error is equal to nil. And here we can actually just do this. So if the auth.compare passwords, the user.password, and here we can transform into bytes the payloads.passwords. So here you're just going to do the same as above. So we're not going to say that the password is wrong. So it could be the password or the email. We're not going to say which one. And at the end, we could just do utils.write.json and say that it is a status OK. And the response could be, let's do something like this, something different, and pass in the token. And we're going to pass in an empty token for now. So if you think about it, when you log in, this is because we're going to make a JWT session. So whenever a user makes a request to an authenticated routes, for example, we're going to start working on the products after and the checkouts. When the user makes a request to these routes, it's going to be authenticated. So we need some sort of token here. And this is what we need to create. So let's go to the auth. And let's create a new file here called jwt.go. And in here, we need to create a function called create JWT, which is going to receive a secret. So this is going to be needed, a user ID, and it's going to return a string and an error. Now, the way you can make the token is going to be with the JWT package, so jwt.new with claims, because we're going to put metadata inside it. It's going to be the signature for the SH250, this one here. Then we need to do the claims, map claims. It's going to be an object, and here you can pass in the user ID. But first we need to convert it to like so. So here, actually, can we do this? Okay, so this is fine. We don't need to do that. So the expire z is going to be the expiration of the token. Here we need to add some time. Let me just do Unix. So the time here is going to be the expiration that we need to configure. I like to make this a configuration of the server. So expiration, and here we can actually define it. So this is going to be time.seconds. And here, let's do time.duration. And inside, so let's go to the configs, our configs.envs, and let's create maybe a JWT expiration in seconds. And inside here, it's going to be a string. And down below, we can make this an environment variable. And we can make it the default value, for example, be 7 days. So it's going to be times 24 times 7, so a week. So the token is going to be valid for this time. Now, this function that I have created does not accept integers. So let's create here another function called getEnvHasInt. It's going to receive a key, a fallback. The key is going to be a string. The fallback could be an integer, and it's going to return an integer. I'm actually going to make this an int64. And here the implementation is going to be very similar to what we have above, but here we're passing the integers. So here you can do getHasInt. And here we need to make this an int64 as well. And now the error should be gone. So now that we have the token, let's do the token has a string. So here error. Let me just delete this import because it's not valid. Token.signed string. It's going to be signed string, and we pass in the secrets. And here I'm just going to quickly handle the error. So it's going to return an empty string, and here an error, and we can just return the newly created token. and a nil error. So here, let's go back to our login and create a token. So auth.create JWT. It's going to return an error as well. And now we need the secret. Now, of course, the secret is going to come from the environment variables, but we need to transform it into a byte size. So here, let's go to the configs.envs and do JWT secrets. So again, we need to create this variable very quickly here. So here I have created the secrets as well on the config, so we are returning it as well. Here we have the secrets passed into the function, and the next argument is going to be the user ID, so it's going to be u.id. We handle the error. Hopefully it doesn't fail here, but I'm going to do an internal server error, and here we can replace the token with the actual token. Save, and let's actually test this endpoint as well. So here I'm on the login, so let's try again with this user. So I'm going to try with the wrong password first, and we got 200, so this is working, which shouldn't be working. Right here, I'm going to start the server again. And here I'm going to make the request with the wrong password first. And here we got the bad request. So we don't know if the email exists, but if we try with a good one, so we got here the token. So the user is going to be logging with this token. And if we inspect the token, so you can go to this application, so the JWT.io. And here, if you paste your token, you can see the metadata that we have just added to our tokens. Here is expired date and the user ID. So we know that is a valid token here. So here I have quickly added a couple of tests for the password. And here I have also added for the JWT, so we can have the authentication testable. Now that we have authentication, we can authenticate the services. So let's go ahead and build the get products. So for that, we need to create a new service called products, or product, because I'm keeping this in the singular. And here let's do again what we already learned. So we create routes.go, and it's going to have a repository as well. It's going to communicate with the database. So here it's going to be on the package product on both files. So here I have just quickly set up the repository for the products. And now we need to add some methods. So let's first go here to the types and add below here the product store. And it's going to have the get products, which is going to return products, types, size to products, and an error. Let's create the product as well here. Now here is the product definition from that diagram. Now there is a very important thing here that I want to mention. This is not the best way to implement the quantity here, because if you think about, I am storing the quantity on the product itself. So if you have here on a database multiple products, the quantity is going to be an integer like 42 items, you know, and this is not the best way to handle this. This is because this is not atomic. So in terms of the acids in the database terms, this is good enough for now as an example. But the problem is that with multiple concurrent requests, this quantity can be false. So here on the improvement exercises at the end of the course, one of them is to implement a better structure to this. So I have a suggestion that as well there that you can implement. Okay, so with that out of the way, let's implement the get products interface here. This is going to be from types dot products. Like so. So very similar to the users, I have just made here a very easy select, and here I made a scan rows into product as well. This is how I did it, very similar to what I have done on the users. So now here on the routes, let's create the handler. And here is the basic syntax for the handler that we have already seen. And here we know that it is already going to have a dependency, which is going to be the repository here. So it's going to be the product store. And here we can pass it as a parameter as well. Store. And here we just need to register our endpoints like so. So here I have just created an empty handler, and this is going to be the signature of the gets all products. And instead here is going to be a get. And now what we need to do is just call that method. So it's going to be the h.store.getProducts. We're going to have a list of products, an error. Let's handle the error here. So we have this just an internal server error, and we write to the user here, write JSON. We can pass in the status OK and the products. So this is how we can easily do a get all for the product. So let's just go ahead and test this out. Actually, first we need to go to the api.go and register our new service. So it's going to be the brand new product service, or actually calling this handler. So the products.new handler. We need the product store. Product.new store, and here the database, and here pass the store. And then all we do is register the routes like we did, and we pass in the sub router like so. So now we can actually test, make run. So here if I hit send, we should get the list of products, and it works because it's giving 200, but it is not returning any product because we don't have any product. So let me just create here dummy product. And this is how we just created a basic product. And if we hit the endpoint again, we get here the data. So we basically just marshaled from the database, and here we have it. Now I'm going to leave to you to create the post method. So the post method is going to be very similar. I just make here the posts, and you need to create some sort of types for the payload, and then it's going to be the same thing as the users. So you can go here into the store, create a new create products method, and then here the routes. All I need to do is validate the payload, create on the database, and return to the user. So I'm gonna leave that to you because I think you can do it. Now that we have the products endpoint, let's go to the actual fun endpoint. It's going to be the checkout. So this is going to be a big one. So let's go ahead and skip to the service here. I'm going to call this cart. And just like the other ones, it's going to have the routes.go. It's going to have the store.go. And I'm going to quickly fill this up with the empty boilerplates. So here is the boilerplate for the service handler. So you just have the same thing here, the register routes. Here's the signature. I have this filled up with the empty checkout function. And here I have also created the cart store, which is going to be like this. And here is the order and the order item from the database, like so. And actually, I am thinking now I'm going to change these to be the order store, because the cart actually does not have a store. So what I'm going to do is I'm going to create here a new service called order. So if you want to create endpoints for the orders, you can do it here, because the cart actually does not have states associated to it per se. It's going to be the orders. So here we can make the order store instead. And here, let's create the methods that we have here on the types, which is going to be the create order and the order items. And these are the methods. So very simple. We have an insert. So basically we're inserting into the orders. And here we get the last ID as well and return it. And here the create order item, we just insert and we forget what is the output. So very simple. So let's start by implementing our checkout here. And before I forget, I'm going to do that later because I think we're going to need more dependencies here. We need to create, we need to actually check if the products exist and all of that. So we are probably going to need the product store here. I'm just going to add it, types.product store. And here as well, like so. And I think this is going to be it for now. So let's start by implementing the checkout. Now, the first thing here is that we actually are going to receive some sort of cart object from the front end. So it's going to be, let's think about it like a slice or an array of items and their quantity. So let me exemplify what I'm thinking. So it's going to be types dots carts checkout payloads. Let's create that here on the types. So it's going to be some sort of item slice. So it's going to be items, which is going to be a slice of cart item. And here the cart item is going to be a product ID and a quantity, like so. So I think this is the signature. And I have here quickly added the validation and the JSON as well for the marshalling. So this is going to be required. So now that we have here the cart, we can actually parse this JSON. And then here below we need to validate it, just like we did on the other endpoints. And now here what we need to do is we need to loop over the cart items and start doing some validations on the items, because we might send some items that are out of stock, that don't exist. So we need to take care of that. So for that, let's go ahead here and create a service, service.go. So on this service.go, you're going to have a couple of business logic decisions. So this is why I have created a new file for that. So here now, let's think about what we need to do. So the first thing is that we can get the products. So we could do something like h.store for the products and get products. And here, let's just get the list and get the errors. Now, it would be handy that we could pass here a list of product IDs, because if you think about it, we don't care about getting the whole database here. It would be nice if we could just get some slice of IDs. So that is what we're going to do. And to do that, we need to go here to the store and let's add a new method. So I have just called it get products by ID, IDs, and here I'm passing in a slice of IDs. So let's go to the store now and implement this method. It's going to be very simple. So this is the implementation. So just copy here if you are following along, because I'm going to move to the routes. If you want to have the code, I'll leave in the description the repository so you can follow along as well there. So here we need a slice of IDs. What we could do here is iterate over the cart, because on the cart we have the items and each item has a product ID, but we need to have the products has a slice. So let's make here let's make here a function. Let's go to our service here and let's create our first function here, which is going to receive the slice of cart items. So types.cart item, and it's going to be returning a slice of integers and maybe an error, because we're going to do a simple validation here. So the products. So let's have here an empty product ID slice with the length of the items. Now we need to loop over the range items. And the first thing we do is check if the item.quantity is actually less or equal to 0, because if it is, it means that the item does not, it doesn't make sense to request 0 items. So let me just return here an error. Invalid quantity for the products. And here just say the product ID. Then I'm just gonna here fill up the array on this product ID. And at the end, we just return the product IDs. So let's just call here the function and pass in the cart.items and handle the error as well, where I'm just going to return a bad request. I think it makes sense. Now that we have the list of products, what we need to do is, if you go here and think about it, we have the products and we need to create an order for the user. So the user ID made an order, we have some status, but then we need to associate some items to that order. So for each order item, there's going to be here a new row on the database. So we need to take care of that. It's going to be a couple of steps. So let's go here into this service and create a function called create order. And this function is going to do a lot of things. So I'm going to also make this a method from the handler, because we're going to need to access to all of the repositories. And this is going to return the order ID, the total amount for the user to pay, and then here the error. Now from this function we need a couple of things. It makes sense to have the products, so let me just add here the products and add anything that I forget. So we also need here the cart items, I think, so carts.item, and the user ID as well to make the table association, and I think that is all. Now here the algorithm is going to work something like this. So we check if all products are actually in stock, so if they are available, then we calculate the total price, and we also reduce the quantity of the products, so we need to reduce the products stock in our database, and then we need to create the orders, and this includes to also create the order items. Now this is going to be a complex function, and in a beautiful world, what you do is wrap everything on a SQL transaction or a database transaction. And I'm actually not going to do that for simplicity, but this is a very good place to do so. Now, just before I start working on here the algorithm, I'm going to do a very quick optimization. Now, we're going to do a lot of looping over the products, and I want to create a map or an object where we can quickly access the product. So it's going to be the product map, just going to be an empty map of integers to a types.products. And this is how I'm going to populate it. So it's going to be, I'm going to range the products, which I have actually called like so. And here what we do is you go to the product map, we say the product.id, and here we say to the products like so. Now the first step, let's here create a new small function, calculate, or actually check if cart is in stock, something like this. We pass in the cart items and the products map. So let me just create this function below. So here is the signature of the function. Let me just here return 0, 0, and nil, just so we can actually, it's still throwing the errors. That's because I need to fill this up really quick, like so. And here it is wrong, it's items. Okay, so I have cart item. Now the first thing we can do is actually check if the length of the cart items, so the carts.items is equal to 0. So if we don't have anything in the cart, we can just return an error, or we can even ignore it, but I'm going to throw an error. Then we need to loop over the cart items. And let's just get the products from the map. So we need to check if it exists as well. So products, and here is going to be the item.product ID. If there is no products, we just return an error. And here we are going to do the stock check. So if the product.quantity is actually less than what we are requesting, we can return an error. And here at the end, we just return nil, like so. So here, let's just handle the error. I'm going to just return 0, 0, and nil. Now let's calculate the total price. So it's going to be total price. I'm going to also create a function called calculate total price. And for the price, we need the items again and the product map. So we need the product there. And this is how we calculate the price. Very simple. We just loop over again the items and we add their prices times their quantity. So pretty simple. And here we need to move to the next step. Let's go to reduce the quantity in our database. So here I'm just going to loop over the items. I'm going to get the product, the current product from the map. So here we do item.product ID. And then we say that the product.quantity is going to be minus the item.quantity. So this is that part of the code that I mentioned that it could be problematic if multiple requests are coming in. So a better solution would be to completely refactor this part here into a multiple table, into a joint table like the order item. And now we need to call this store and update the stock. So we need to do an update store for the product here and then to do an update product. So I'm going to quickly implement that here and pass in the new product like so. So let's go to the types and implement here the update product, which is going to receive a product, and it could return, let's just return an error. Let's go to the store for the products and implement that function here. And this is the implementation, very simple, just an update statement. And here now we can actually update our product. Then the last steps we need to do is actually, let me just here update the price because we already have it. Now we need the order ID, so that is what we're going to do. Order ID and error. And here let's go to the order store, which is the store like so. Create order. Let's do types dot new order. Let's pass in the user ID. Then we also need the total. This is going to be the total price. The status, the default is going to be pending, for example. And the address here going to be some address. I'm going to leave this hard-coded here. Now I'm going to keep this hard-coded here because one of the improvement exercises is to implement an address, a user address table. For example, in Amazon, you can have multiple addresses and you can here fetch the default one. So for example, this is one of the exercises. So I'm keeping this like this. And here we need to send the order ID. And here very similar, I'm creating all of the order items. So for all items, I'll create a new order item in the database. So let's go to the routes and actually call this function. So it returns first the order ID, then the total price, an error, and let's just call it create order. We need to pass in the products, the cards.items, and the user ID. We currently do not have it. Now I'm just going to define it here, which is could be like 0 for now. Now this user ID is coming from the token, from the JWT token. We're going to create a method in the bits where we can actually fetch this user ID from the authentication when we add authentication to this endpoint here, because currently it is unauthenticated. So one step at a time. So here let's just handle this error and finally return to the user the right JSON with this data. So it's going to be a status okay, the map, and here I'm going to return a custom map with the total price, which is going to be total price, and then the order ID as well, like so. Alright, so the endpoint is pretty much done, and before we can actually test, let's first add authentication to this endpoint here. So the way that I like to do this, and it's a very nice way, is to use a higher order function or a decorator pattern or whatever you want to call it. The idea is that we're going to wrap this function here with, for example, with JWT auth, and here we pass in the function. So before calling the handler, it's going to be calling this function here, which is going to do the validations. So let's go to here to the authentication into the JWT, and let's create that function. I'm going to be calling this with JWT auth, and it's going to be taking the handler func as we saw. So it's going to be http.handler func, and it's also going to receive the store. So we need to access to the user store, so we can actually fetch the user by his token ID. So here let's do http.handlerfunc. We need to also return one, so it's going to be a function that returns a function. So let's do func here. Use this option for the autocomplete. So the first thing we need to do is actually check if the user has a token in the headers or the cookies or whatever. So first we need to get the token from the user requests. Then we validate the JWT to see if it's alright. If it is, we need to fetch the user ID from the database, because we get the user ID from the token, right? And the last step is that we set the context user underscore ID value, for example, or something like user ID. So we're going to change the request context to the user ID, so we can have the user ID here on the handler. So here I have just imported with the correct function, and I'm going to pass in here the user store. So we actually need a new store here, which is going to be the user store, types dot user store. We have already created it before, user store, like so. So this method here is wrapped with the function. So let's go ahead and implement it. So I have here just created a very simple helper function, so we can just get the token with a function call, so get token from the requests. And now you need to validate the token. So here I'm going to create a function as well called validate token, which is going to receive the token string, and it's going to return a pointer to JWT.token and an error. Now the only thing we need to do here is call the JWT.parse. It handles all of that for us. The first thing is that we need to pass in the token string, and here we need to pass in a function. And here we need to validate the token.method, so we need to check like so. So let's get the methods, and if it's not okay, let's return nil and an error called like so. And here we need to actually type this to the correct name here, so we need to do a casting to the signing method, which is this one. And here let's just return at the end the byte slice with the config.envs.jwt secret that we already created, and nil. Now if we have an error here, let's handle it. I'm going to first log for an error because it might be handy. I'm going to return, and we also need to return to the user that he has permission denied. So what I like to do here is create a function called permission denied, because it's going to come in handy because we're going to call this function multiple times here. And this is what we're going to do. So we're going to just call utils.error and do that. So you can easily do that. And finally, on this part of the algorithm, we can check if the token.valid, and if it's not valid, we need to return permission denied. Now here, let's fetch the user from the database. But first, we need to get the token ID from the user ID from the token. So this is how you can do it. And then here, let's get the user ID. We need to convert it to a string. And then we can actually call the user store, or did I call this store dot get user by ID? And here you can pass in the user ID like so. And if the user doesn't exist, we handle the error again, just the same way. And finally, let's add the user to the context. So let's do r.context. Let's get the context from the requests. Then we are going to do a context with value. So let's initiate a new context with this value here. We're going to pass in a key. So it's going to be the user ID, and the value is going to be the u.id. And here we just modify the context of the request, and we can actually call at the end the handler func very importantly, and we pass these parameters here. Now, the compiler is going to warn us that we should not do this as a string. What we could do is create a new type. So I'm going to call this user key, and it's going to come in handy because we need to reference this key as well. So this is going to be a constant, so it doesn't change. So I'm going to call this like so. It needs to be context key, and it's going to be equal to this one. And the context key is just a string here, like so. So we have our own type for the context, and now we can access that type here on the routes. And just before we can actually do that, let me create here a helper function for us to get the user from the context. So get user ID from context, and we're going to receive the context.context and return the ID. So the first thing we do is we check if the value for the user key exists. If it doesn't, we can just return, for example, -1. And here it's okay, not an error. And if it exists, we just return the user ID. Now we need to cast this value as well to an integer, because we know that that is an integer. And then here on the routes, we can just call this user ID with the auth.get user ID from context. And here we pass in the request.context contexts. So with that, let me just save here the files. And here, are we actually using this user ID? We are sending it to the function. So everything is nice and tidy. Let's go ahead and actually test this. So I'm gonna just restart the server, make a run. The server doesn't start because we actually need to go to the api.go, and I always forget this. So we need to create our service and update the services that we have changed. So the product is depending on the product store. But I think we have broken the implementation of the interface. So here I'm just going to delete this, and hopefully it's how it needed. And apparently there is a typo here, so let's just add here an S so it's compliant. So let's just initialize the cards, actually the card store now. Actually, we need to do is the card handler. So let's do cards.newHandler, and here we need to pass in a couple of stores. So the first one is going to be the order store. This one we need to initialize, so order store. It's going to be new order.new store. Pass in the database, and we pass into here. Then we need the product store and the user store finally. And here you're getting an error here. That's because we are calling the struct and not the constructor. So let's go card handler.register routes and pass in the sub router. So this is the last time we actually need to do this. And now if we try again the make run, the server has booted, and let's actually test. So this is the checkout. Here I have a product 1 and a product 2. Actually, you don't have a product 2 yet, so let's actually create it. So here I have just created a new book product. Even if we try to hit our endpoint, we have a permission denied because the endpoint requires authentication. And here I have on the headers a token, and if I hit send, and here we got the order ID and the total price. And if we check the database, we have here a new order created and the order items also created. And in the products, we have the quantity reduced to the amounts that we have purchased. And when I say that wants to buy 200 of the product 1, and if we hit send, we get the error product t-shirt is not available. So this quantity is not possible to buy. And if you try with the product that does not exist, we also get, we're getting this error, but if we try with this, we get the product 22 is not available in store. And so this pretty much sums up everything, and we have completed the project that we are set to build to. Now again, you can get the full codes on the description below, and if you liked this video, consider subscribing and leaving your like. And consider also joining the free Discord community, where there are plenty of experienced engineers that can help you, and you can leave your questions there. So if you have any question regarding this project, you can leave on the Discord below as well. So thank you for watching, and see you on the next one.